Hello, my name is Sandy Habins and I'm the General Manager of Gaisler in Sweden. I'm going to talk to you about the Leon 3 and Leon 4 processors and how they can be used on micro-semi devices. Let's start off talking about our mission and what we want to achieve. We really want to provide processors that enable new scientific missions and also allow new ways to utilize our technology in space constellation for commercial use. So we really want to be the mission enabling technology provider and also at the same time trying to reach out to the new space initiatives. The way we are achieving our mission is by providing technology that is based on open technical specifications that are freely available to individuals and entities that want to develop their own microprocessors. We have selected the SPARC standard. SPARC stands for Scalable Processor Architecture. And we have developed a series of processors based on this specification. The way we achieve our mission is by developing technology that is based on an open set of technical specification that is available to individuals and entities that want to develop their own microprocessor and semiconductor devices, and they're based on published open standards. We have developed several processors in the Leon series that are based on the SPARC standard. We have of course not only developed the Leon processor, but a complete infrastructure around that. You cannot be really successful as a processor company if you only do the IP core, the processor, or just the hardware. We actually provide everything. We try to be a one-stop shop for everything that comes around the SPARC processor and the Leon core itself. So we have the synthesizable IP cores that we are selling. We offer compilers, debuggers, operating systems, simulators. We use the IP to put it inside our own silicon, so we have our own silicon generated, as well as putting the IP inside the FPGAs like those from Microsemi and offer pre-programmed products. In addition, we put all these components also on development boards, either specifically for our own devices or devices from companies like Microsemi. And in the end, we also take these boards and integrate them in system test beds. So we actually support the Leon processor and the peripherals all the way from the IP through the silicon, through the boards, through the system, through the operating system compilers and drivers, etc. So basically a completely vertical solution, a true one-stop shop. But let's start at the beginning, at the basis of our product offering. We have a library called grlib, IP core library, which is a concept of an environment where we develop IP cores and which we can transfer easily between technologies. We have processors, peripherals, memory controllers in this library that can be used to target any type of technology. We base that on the AMBA bus, on-chip bus with plug-and-play information. So we have extended the bus to give additional information to the debuggers and operating systems using it. We actually provide two different versions of the library. We have a fault-tolerant version, which aims to service the space market, and a standard version which can be used in the commercial market, aviation, etc. We also have a large support for tools and prototyping boards. So every FPGA or every ASIC comes very often with an own set of tools and own set of prototyping boards that are commercially available. So we try to support all those tools and all those boards that are available. The portability between technologies is very important for us because we see a clear need for customers going from let's say an FPGA implementation at one stage and later on to an ASIC implementation. So it has to be easy to go between them, has to be easy to do prototyping. We have template designs, for example, for RTJ4 development kit. We have that for Iglo 2 and other development kits. So it's very easy to start using this technology that we offer because we also have pre-designed template design and pre-designed and generated bit files that can be downloaded. And what is important to this is of course that we have a very clear technology abstraction layer between the IP cores and the tech-specific cells at the bottom. But of course the core of the matter here is the Leon 3 FT and Leon 4 FT processors that we offer. These are Spark V8 processors. They are 32-bit processors, 7-stage pipelines. They have multi-processor support. They have a large variety on the usage of multi-set caches. They have optional memory management unit, floating point unit, and a really integrated on-chip debug support unit with trace buffers, so non-intrusive debugging can be performed. It's highly configurable, so we can configure these cores as small, like microcontrollers, all the way up to high-end processors. And actually we do specific optimization for the technology that we're targeting, like the pipeline is different for a ASIC as it is for an FPGA. As the same thing with the fault tolerance, we optimize it specifically to the target technology, because for example in an FPGA you have a fixed sized memory, or you might even have some kind of fault tolerance built into the memory that we can take advantage of. If you look a bit on what we can achieve in terms of performance, in the past we've been using a lot of RTX devices and ProASIC 3 devices, and we can achieve about somewhere between 20 and 35 megahertz depending on the configuration. And now with a new RTG4 technology available, we can double this, so we are in the range between 50 and 80 megahertz. I will go into more details in a while. Now those cores are certified by Spark International, so it means that we are compliant to the standard, and these cores are actually the baseline for most processor in space projects in the US, Europe, and Asia. But of course, a processor doesn't come alone. We need a lot of IP cores around it in order to support peripherals like SpaceWire, MIL standard 1553, Ethernet, Space Fiber, PCI, USB, SPI, CAN, and also a lot of encoder and encryption IPs like Reed-Solomon, AES, ECC, as well as support for space-specific interfaces like CCSDS, telecommand and telemetry, as well as lossless compression. So for each of these cores, we actually have a calculated utilization number. So it means in terms of resources for RTG4, ProASIC 3, and RTX. And all this documentation is available in a extensive user manual for all the IP cores, and it can be downloaded from our website. So we take these IP cores that we have in our portfolio together with the Leon processor, and we have built a couple of pre-programmed FPGA-based products. So the first one we started off was the Leon 3 FT RTX, and so we actually had 8 different configuration of this FPGA. So some of them were actually requested by customers, and we put them in our standard portfolio. So the basis is a Leon 3 FT processor with 8K instruction cache and 4K data cache, optional hardware multiplying divide, and also optional memory management unit and floating point unit. So we can configure this one in many different options, and it's all limited actually by the size of the smaller RTX 2000 device. We've also taken exactly the same technology and reused like the SpaceWire interfaces and the SpaceWire router, and did standalone SpaceWire router product out of that. And we offer these both as RTX devices and pre-programmed ProASIC devices. Our latest addition to the offering is support for the RTG4 device. So here we have actually started off with providing programming bit streams for the RTG4 development kit. So we offer a Leon 3 FT design and the Leon 4 FT designs, actually multiple of them, configured slightly differently so people can evaluate these the products. So anyone can go and download the bit streams from our website, upload them into their RTG4 eval board, and start using it immediately. So there is no license required. You can download immediately. They're actually not suitable for space flight because they actually don't utilize the FPGA 100%, and they're also locked to the development kit. But again, you can download them. They will provide you with speed and resource utilization figures for the IP cores. They will also allow you to start using software and do performance evaluation. And to support that, we have an evaluation version of our monitor freely available as well for download, together with compilers, operating systems, etc. So it's quite easy to get started immediately. If you look closer at the implementation of the Leon 3 FT on the RTG4, we've taken here an example, which is one of the template designs that we have. It includes, of course, a Leon 3. It includes bridges to the AMBA on-chip bus and other things that are needed to develop or use a useful processor like UARTs, timers, interrupts, and so on. So we've taken this sort of basic design and looked at it from different angles. First of all, we can do a really small, tiny system. So what we do here, we just take a minimum number of register windows, which is 2. We don't have any caches. And as you can see, we're down below 2% of utilization in an RTG4. And this is an RTG 150 we're looking at. And the speed we can achieve here is about 80 megahertz after place and route. We can also configure the system to be a bit stronger, a bit larger, like we call the minimum system. We have a general purpose system, which again is more, more resources are being used. And in the end, we have the high performance system. And you can see here that utilization is approximately less than 4, less than 9, and less than 20%. For those configuration as well. And of course, the performance of the operating system is being reduced accordingly, because the more resources we use in the FPGA, the more complex the design is, also the routing resources, and the speed goes down at the end. We also do the same exercise for a Leon 4 FT on the RTG4. So here we actually have a bit more performant machine. It consumes slightly more resources, but it also gives better performance. So if we compare a Leon 4 to a Leon 3, the main differences are that the internal bus in the Leon 4 can be configured 128-bit wide or 64-bit wide versus the fixed 32-bit internal bus inside the Leon 3 system. Also, the number of drystone MIPS per cycle increases from 1.7 versus 1.4 in the Leon 3 FT. We also see higher Spec in 2000 benchmark performance values when we enable the L2 cache, which we don't have available, which is normally used with the Leon 4. So we get a similar operating frequency, about 5% higher for the Leon 4 FT, but also we pay a bit in resource utilization, about 15% more. So both Leon 3 and Leon 4 actually take advantage of the built-in SRAM EDAC that exists in the RTG4. And if you look now at the percentages, you see that even a minimum Leon 4 system utilizes about 4% of the RTG4. The general purpose is about 10% and the high performance system is about 24%. But also here the frequencies are slightly higher than a comparable Leon 3 system. To conclude, I would like to point out a couple of benefits of the Leon technology. First of all, it's very flexible. We can move it between different target FPGAs, target ASICs, and in this case we have used RTAX and the RT-Pro ASIC 3 FPGAs to design pre-programmed solutions for platforms, payloads, and instruments. You don't really need to be a designer. You can just buy a part with the Leon inside. So it's also very quick turnaround time for custom configurations. We offer the same templates designs that we use for the standard products. We offer them to customers who want to do alterations, modifications. And of course, there are the lower cost prototype solutions available. We can use the AX part or the just as general ProASIC part for doing prototyping. And again, they have very similar performance. The library, which has over 100 peripheral IP cores, comes with the Leon 3 or Leon 4 options. So again, it's quite easy to change between the Leon 3 and Leon 4 in the future. We have optimized designs. We have optimized the Leon 4 for the RTG4, and we have template designs available. And we see there is a significant performance improvement from Leon 3 on an RTAX 2000 compared to the new RTG4 device. We can definitely see that improvement. And again, the bit streams are available from our website. You can go there today and just download them and use them immediately on your favorite eval board. So we provide pre-programmed components, tailored design, template design with our IP core library. So whatever you need, a component or an IP core, we're there to support you. Thank you for your attention.